Okay, so if we're doing the tangent function, you have to remember that when we're doing tangent in a triangle, it's opposite over adjacent, so it's y over x. So if we remember, our point is going to be sine over cosine. So if you use your trigonometric circle, you can wait. Okay. So if we look at 0 on our trigonometric circle at 0, okay, imagine your circle here. At 0 here, the coordinate is 1, 0. Instead, the first one is cosine. So if we do sine over cosine, we get 0 over 1. So 0 over 1 is 0. I'm going to use pi over 4 here, exactly in the middle. Pi over 4. What's the value of sine? Square root of 2 over 2 over... so what's this? It's 1. At pi over 2, when we're on the top here, the coordinate is 0, 1. If we do sine over cosine, we get 1 over 0. Can we do that? No. Okay, there's no value here. And if we keep going here at 3 pi over 4, what's the sine value? Is it the sine that's negative or the... Here? It's the cosine that's negative. So it's going to be square root of 2 over 2 over negative square root of 2 over 2. So that's negative 1. And at pi, here we need to do the sine over the cosine. 0 over negative 1, 0. So if we keep going here, 5 pi over 4, because it's going to be negative square root of 2 over negative square root of 2 over 2. So again, it's 1, because both negative they cancel out. At 3 pi over 2, when we're at the bottom here, that's what? It's negative 1 over 0. So again, we cannot figure it out. We cannot find the solution. And 7 pi over 4 is it plus or minus? The sign here?
The cosine is a plus.
Yeah, the cosine is plus. So square root of 2 over 2. So again, it's negative 1. And at 2 pi, we're back to 1 and 0. 0 over 1 is 0. So when we want to graph it, yeah, it would be the same. It's going to repeat on the other side, right?
But would the sign be changed?
The sign? Like if we're going backward? We're going to do, if you want, we're going to do this part and you can see after what's going to happen. Yeah, you see that some of them, they're not defined. So when we graph it here, so we start at 0 and we realize that at, oh, I don't have my graph. Oh no. Oh, we're okay. So we see that at here, at pi over 2 and 3 pi over 2, it's undefined. Okay, so I'm going to come here, pi over 2 and 3 pi over 2 is going to be undefined. That means we're going to have asymptotes here. So what do you think is going to happen when we go backward? It's going to be the same thing here.
Because so when it's not defined, it becomes asymptotes.
Yeah, because it means there's no value, right? We cannot find a value. So there's no value here. Okay, 1, 2, 3, 4. Wait. Doesn't work, I think. What doesn't work? Look here, that's pi over 2. That's 2 pi over 2 here. So, yeah, sorry, this is 2 pi over 2. And that's 3 pi over 2. And you'll see why I did it like this. Okay, so at 0, we said it's 0. And at pi over 4, what did we say? It was 1. So at pi over 4, it's 1. And at, if I keep going here, the other one was 3 pi over 4. Negative 1. So you see, if I want to graph this, I'm going to need to go back to my negative pi over 4, right? And if you see, it's repeating. So, where? This one here?
Why do we exist? We always exist.
Well, the asymptotes are going to repeat, right? Because it's a periodic function is going around. So it's going to repeat every, what do you see here? Every 2 pi over 2, that's the same as pi. So every pi is going to repeat. Okay. And if I want to graph this part here, I would need to go on your sheet. You have it at negative pi over 4. What did you find for your value at negative pi over 4? It's negative 1, right? So if you look at this, and we would need to find many other points in between to really see the curve, because we know it's not going to be a line, right? So if you use your calculator, you can find all the other points in between. And what it's going to do is going to come like this, touch this, and go up like this. And that you can just find it if you find many points. You can sit on your calculator, or we can find more points, but those are the main important points. If you have these 3, you're good and you're asymptote. Okay, so here again, we're going to repeat it, and it's going to be like this. Oops. Like this. Yeah. Negative pi over 4, and here negative pi over 2 doesn't exist. And then we would repeat it to the left, to the right. On your sheet. Yeah. Oh, yeah. Yeah, sorry, my scale is not right on your sheet. Huh? Your scale is too stretched on your sheet. Huh? Yeah. So just well, either change the scale. If you want to change the scale and make it look like this. And the other people, I'll tell them I'll give you back your sheet on Tuesday. So you see that it's a bit different than the other one, right? Wait, we're missing. Okay, I'm just gonna add. So what is it gonna look like? The function of tan gonna be a tangent again of b x minus h plus k, right? And what you have to remember in your head when you think about tan, it starts at 0, 0. It's coming like this, going up, and there's asymptote here at pi over 2 and negative pi over 2. No, that's just the tangent of x.
That's when there's. How do you find when there's no value? When it's like just this, like if you found it.
So you have to go in your circle. You have to remember tangent is always sine of x over cosine of x. So let's say you want to find at 3 pi over 2. Okay. What you have to do, you have to go in your circle. Where is 3 pi over 2 in your circle? Pi over 2, 2 pi over 2. It's here. What are the coordinates here? 0, negative 1. So you have to find sine. That's it. Okay, so you have to always refer to your circle, find the sine and cosine value, and divide them. Okay, so you see this graph here? That's your general idea. So A, if we change A, can we talk about amplitude here? The amplitude? No, because it doesn't add. But this is going to give you a vertical stretch. So sometimes instead of being like this, it's going to be just more narrow or more compressed. Yeah, exactly. Yeah. Okay. Your B, if you remember, it's horizontal compression. Right? So again, it's like it's going to squeeze like this. It's going to change just the general shape. Your period, it's still the same, but it's not 2 pi in this case. You have to remember it's pi over b. If your B is different, then you're going to have to find your period. Right? Your H, what's your H for? It's your horizontal translation. So it's going to move left or right. And your K? What's... Yeah, but instead of being here, it's going to be... So vertical translation. If your A is negative, what's going to happen if your A is negative? It's a reflection on X axis. Yeah. Because A usually it's like this, so reflection up and down. And if your B is negative, it's a reflection on Y axis. Good. So we're just gonna try to graph one, and we're gonna work less on the tangent function than on the sine and cosine. Okay, you need to learn it, you need to be able to graph it, but we're gonna do less work. Wait. Try to graph this one. So what do we know about this? Starts be careful, because this here is not like there's no axis, remember? So there's going to be a vertical translation of 5. Okay, so instead of starting on the axis, we're going to go up. Okay, here, horizontal translation. So 2 to the right, right? Okay, what else can we find? Okay, so if we're just looking at these two, instead of starting at 0, 0, we're going to move 2 to the right and 5 up. So we can find our starting point. It's going to be, our starting point is going to be 2, 5. We can go and graph that. 2, and I'm going to just go by 2 here. 2, 4, 6. So 2, 5. I'm going to start here. Can I find my period? Yeah, how can I find my period? Pi over B. B is pi over 6. That's the same as 5 times 6 over pi. And that's the same as 6 pi over pi. And that's the same as... You can cancel the pi. So if our period is 6... if the period is 6, that means you start at 2. You're going to repeat where? 4, 5, 6. When do we repeat then? If our period is 6 and we start at 2, we're going to repeat 1, 2, 3, 4, 5. So we're going to repeat it here. Because the period, that's what it means, that we're repeating every period. But we know, remember, the period means we're going to repeat every period. So if we have a point here, we can come and put this point here. And then what's missing is our asymptote, right? So how do we find our asymptote? Okay, so you know that, imagine your tangent here, okay? That's the regular tangent that was like this, right? And we're repeating here, right? So right now we have these 2 points. Where is the asymptote? Exactly in the middle. Okay, so where is the asymptote? In between. So between 8 and 2 is where? Add them up. Divide by 2. So at 5. So 2, 3, 4, 5. So we're going to have an asymptote here. No, that's it. Yeah, yeah, exactly. Yeah, it's always in the middle. So here I'm going 1, 2, 3 that way. See, 1, 2, 3. So I'm going to go 1, 2, 3, and I know I'm going to have another one here. And are we going? Is it okay? 1, 2, 3. No, oops. There. And am I going to graph going up or coming down? Because there's no reflection. Okay, so we can start finding different points, but if I want you to sketch, you're going to go like something like this and then sketch like this. If we want to find here, we would plug in 0 here, plug 0, and then calculate your value. Or you can calculate, plug in your 0. We're going to learn that in the next chapter, how to do it more precisely. It's just a rough idea of your tensor. Okay, so that's a quick one. We're going to come back next class on that. But with that, at least you have a rough idea of what it is, and you should be okay to start the last 3 numbers. Well, number 5, it was already assigned. I just want to